Okay guys, this is like my third attempt to make a video from home for you guys. I have not been able to get any of my document cameras working on my home laptop, so unfortunately for the time being, I'm going to be making videos with my phone. So I apologize that these aren't super high quality, but it's the best I can do for now. Hopefully I can figure out how to get the better tech working soon. So thanks for bearing with me. This is the part 2 of the 7-4 video notes. So the first part showed some of the vocab in example 1, and this is going to have examples 2 and 3 from the 7-4 notes. So let's get started. Here we're taking a repeating decimal and we're going to be writing it as a fraction. And we have to be a little creative about how we do this, because thinking about 0.888 dot dot dot, that is 0.8 repeating. And what we want to do is we want to use algebra as sort of a hack here. So there's this idea that if I multiply this by 10, I'm going to get 8.8 repeating. So if I could somehow do that and subtract those values from each other, all of those repeating decimals will just disappear. So we're going to do that. We're going to say, okay, let's pretend x is this number, okay? So if I say the value of x is this repeating decimal, then I can easily multiply both sides by 10. And that will tell me, and this is not, it is not obvious why we would do this, okay? It's not obvious to a lot of people. I don't expect it to be obvious to you. I just want you to understand why it works once I show you that this works. So 10 times x is 10x, and 10 times 0.8 repeating is 8.8 repeating. Okay, it's still a bunch of repeating 8s. I'm just putting a decimal there. And I'm not putting the line up there, although it wouldn't be wrong to do that because it would still be followed by an infinite number of 8s. So what I'm going to do now is I'm going to subtract these numbers from each side. So I'm going to subtract this x, which is 1, from this side. And because that number equals 0. repeating 8, I'm going to subtract 0. repeating 8 from this side. They're the same number, so I can do that. And that's going to leave me with 9x equals. So now these repeating 8s cancel, and I'm left with 8. Okay, so that now gives me 9x is 8. And if I divide each side by 9 to get x alone, I've got x is 8/9. But over here we said x is 0. repeating 8. That means that 0. repeating 8 is 8/9. In fact, 0. repeating anything here, if it's a single value following the decimal place, we can rewrite as out of 9. So for example, 0.1 repeating is going to be 1/9. 0.7 repeating is going to be 7/9, and so on. This one's a little different because I have 1.25 repeating. Okay, so in order to write this as a mixed number, 1 is 1, so I'm going to ignore that, and I'm going to just deal with the 0.25 repeating piece for now. Now, because that's 2 decimal places that are repeating, so it's repeating in the tenths and hundredths, what I want to do is I want to take the same approach I did, say 1x is 0.25 repeating. Therefore, 100x is this times 100. So I'm going to slide the decimal 2 places to the right and call it 25.252525. So again, that 25 is repeating. Okay. And the same thing, I'm going to subtract that 1x from each side, only on this side I'm going to call it the number version, 0.25 repeating. So here I have 99x, and here I have these cancel, 25. So x is 25/99 when I divide each side by 99. Okay, so similar rule, except this is 2 place values following the decimal. So I have that this 0.25 repeating is 25/99. So if I write it as a mixed number, bringing that 1 back in, it's 1 and 25/99. So this is the same as 1.25 repeating. So if you have 2 decimal places that are repeating and they immediately follow the decimal point, we can simply write it as this value over 99. It gets a little bit different when we have something like this, 0.16, and only the 6 repeats. So here we have to be a little bit more creative. So let's see how we approach this. This is example 3, and it says the weight of an object on the moon is about 0.16666666 times its weight on Earth. That 6 repeats forever. An astronaut weighs 192 pounds on Earth. How much does the astronaut weigh on the moon? So weight on the moon, mass doesn't change on the moon, but weight does, because the gravity on the moon is much less than the gravity on Earth. And the reason is because the moon is less massive than the Earth. So if we want to know how much does a person who weighs 192 on Earth weigh, we need to multiply by 0.16 with the 6 repeating, okay? That will give us their weight on the moon. And that's because we're multiplying by a number that's less than 1. When you multiply by a number less than 1, the value goes down. It can be awkward to multiply by a repeating decimal, so we're not going to do that. We're going to turn this first into a fraction. So to do that, we're going to take that same approach. We say x, or 1x is 0.16 repeating. Now, there's only one repeating place value, so I'm only multiplying by 10. Even though the repeating place value is in the hundredths place, I'm still going to just multiply by 10. And that's going to give me 1.6 repeating. Okay, because I'm sliding this 1 decimal place to the right. So if I subtract the 1x and subtract the 0.16 repeating, watch what happens. So this might feel a little weird, so we can actually extend out the 6's, right? Because those are going to go on forever. So if I do that, I can imagine that if this 6 repeats, I don't care if this 6 repeats. I see it repeat here, so I don't really need to consider the bar on top of this 6. So I have 9x on the left, and over here, these repeating 6's cancel, and I'm left with 1.5. So again, I'm treating this 1.6 as 1.66 repeating. So these are the same number, even though they look a little different, because if this 6 repeats, it's the same as this 6 repeating. I can just sort of treat it like a 6 by writing it this way over here and subtract the 1, and I'm left with 5. So if I solve for x here, I have x is 1.5 over 9, which it's awkward to have a decimal in a fraction. So if I double the top and double the bottom, I get 3/18